Just to recap, you need these supplies. You need your homework, which is for grade today. So you need this sheet of paper. Make sure you have that out, ready to grade. In addition, you need your egg osmosis experiment. So we're going to turn that in at the end of class. For those of you joining us virtually, what you're going to do is turn this sheet of paper in to me via Google Classroom, and then turn your egg osmosis experiment in on Google Classroom as well. Now, by the end of class, we'll know what prokaryotic and eukaryotic cells are, plus we get to watch a video over them, and we get to decipher and pick out scientific truth versus lies. Theory. Well, theory is not 100% proven, is it? So I want to see if you guys can help me pick it out, okay? All right, so first things first, let's go ahead and review that homework. So go ahead and pull out your living cells are made of these. Make sure your name's on your... All right, once you get your notebook ready, let's also open up our textbook. We're going to learn more about these two types of cells. We're going to learn about them on page 66. So please open up your notebook, your textbook, to page 66. Page 66 of your textbook, please. All right, so as you're getting ready, we're switching gears to two types of cells. Alright, so what page are we on, guys?
66.
Ooh, you guys pay close attention. Let's go. Now, what's our title?
Types of cells.
Types of cells. All right. So let's dive into these two types of cells and see what we can learn about them. So you can take any cell on the entire planet and you can classify it as one of these types. In fact, you might remember back when we had all these taxonomy levels. Remember we said the biggest one was kingdom. But then we added an 8th level, didn't we? Who can remember that 8th level of taxonomy that we added?
Domain.
Domain, right? In fact, today deals with domain. Like I said, any cell on the planet can be classified as one of these two cell types. So, you've been introduced to them already, right? What are the two cell types? Tyler?
Prokaryotic and eukaryotic.
Whoa, you guys are like incredible. Do you guys realize that you're doing phenomenal on your grades? I think every single person in 7th grade life science has an A or B in science. In fact, you guys are really impressing me. I'm thinking maybe we can kind of crank it up a little bit. What do you think? Crank it up a little bit? Because you guys are doing stellar with the book so far. I mean, we're just covering what's in the book, but I'm seeing that what you learned in your previous grades, I'm very impressed. Okay? So, we may crank it up a little bit since you guys are doing so phenomenal. Alright, so we're going to dive deeper into prokaryotic and eukaryotic cells. So, let's get things started here. Page 66, please follow along in the reading. What I'll do is leave some words out, and you please help me fill those in, okay? So everyone's following along. Cells come in all sorts of shapes and
Sizes.
All cells, however, fall into one of two major
Categories.
They are either
Eukaryotic.
or.
Prokaryotic.
So let's get introduced to them. How about one of you guys read and tell us about eukaryotic cells? All right. Right here, Lionel. Thank you.
Okay. Most kinds of organisms are made of eukaryotic cells. The cells of protozoans, algae, fungi, plants, and animals are all eukaryotic. The plants that make up your body are also, the cells that make up your body are also eukaryotic. Eukaryotic cells have a true nucleus. In other words, their genetic material is surrounded by a nuclear membrane. Eukaryotes also contain most or all of the organelles discussed in the previous section. The plant and animal cells in figure 3 through 6 on page 63 are typical eukaryotic cells.
Ah, thank you so much. So, what were the two types? Prokaryotic and eukaryotic, right? So let's make sure and add those two types to our notes. So any cell on the planet can be labeled as one of the two types. It could either be eukaryotic, which you know you are made of eukaryotic cells, or it could be a prokaryotic cell. Now the ironic thing is, that fits right into the two domains, doesn't it? We learned that any organism can be classified into domain eukaryotic or domain prokaryotic. Ah! So we're diving deeper into our classification, aren't we? All right.
Yeah, I have a question.
Yes, what's your question?
So, you said domain didn't exist when this book was written. So were
Right.
eukaryotic and prokaryotic something different back then?
Ooh.
Or what were they before they
Now,
were written?
obviously, these kind of cells have existed for thousands and thousands of years, right? But scientists did not add that biggest level of classification until just the last 5 or 6 years. Now, on the other hand, we know they've existed. We just didn't add that classification level until recently, which is pretty cool, isn't it? All right, so eukaryotic cells. Thank you for reading and sharing about eukaryotic cells from the text. Here are some things you need to know. Get it? You need to know about eukaryotic cells. They do not have, they do have, they do have a true nucleus. What? What does that mean? So they have a true nucleus. Huh? As opposed to a false nucleus? What? So let's figure out what that means as you write this in your notes. So yes, eukaryotic cells do have a nucleus, but their nucleus is what we call true. And by true, we mean that it's kind of contained all together. So for example, in this cell model we've been focusing in on, you know that this animal cell has a nucleus, right? Now if you look at the nucleus, it has this white outer lining holding it together. So a eukaryotic cell always has a nucleus that's contained and held together. It's held together by that membrane or that covering around it, okay? Now that's an animal cell. What about a plant cell? Does a plant cell have a nucleus, guys? Well, of course, you know that. You're cellular experts, right? Is the nucleus wrapped with a covering? It is, and you can see that, can't you? So these two cells are both eukaryotic because they both have a nucleus wrapped up in this covering or nuclear membrane. Does that make sense? All right, a few other things you need to know about eukaryotic cells. Okay? Eukaryotic cells are more complex, they're more complicated, they have more parts and pieces. And you can see that in illustrations. The prokaryotic cell is pretty simple. The eukaryotic cell has a lot of parts and pieces, just like your cells, right? So let's add these, and then I'll take Tyler's question, okay? Eukaryotic cells contain most of the organelles that you've been learning. So the big 6 that we learned, eukaryotic cells would contain most of those. Now some awesome examples of eukaryotic cells. You, of course. You are made of eukaryotic cells. Also, all the animals in the animal kingdom are made of eukaryotic cells. All the plants in the entire plant kingdom are made of eukaryotic cells, and so are fungi. Ooh. So molds, mildew, mushrooms. Also algae, like the pond scum you might find on a pond. And even protozoans. They're little one-celled organisms that live and float around in water. So all those are made of eukaryotic cells. Yes, Tyler, what's your question?
I was thinking about, so when we were talking about the nucleus,
Mhm.
and like the nuclear area and that, does the nucleus have anything to do with a nuke?
With a newt?
A nuke, like a bomb.
Oh, a nuke. Like a nuclear bomb. Ooh. That it has everything to do with a different type of nucleus. All right. Cells have a nucleus, right? But so do atoms. If you take an atom and you split it apart, that is creating a nuclear bomb. So yes. So nuclear bombs don't have anything to do with eukaryotic cells, but everything to do with atoms and their nucleus splitting. But not the nucleus of a cell. Good question. Yes?
Sounds like it works.
Thank you.
Good question.
I didn't miss one of these guys.
Oh, okay. Yeah, absolutely. Yes, Jill?
So, our cells are like,
You're welcome.
known as like animal cells, right?
Yes, technically we're classified as having animal cells.
So we're not animals.
Correct.
So, how does that?
So we have eukaryotic cells just like the animals. I like to point out we're definitely very different than animals. And we know that because God made us in His image, right? He didn't make the animals that way. But yes, He did make us with the same type of cells. Which makes sense, right? He's the same creative God. He's going to use the same creative ingredients. It makes sense. All right, great question. All right, so that's eukaryotic cells. And remember, you are made of eukaryotic cells, right? So let's look at the other type of cell. What's a prokaryotic cell? How's it different? You have them on your body. They live as bacteria and germs on your hand. They also live in your gut. Ew. So what are they? How are they different? Let's have someone to read the next paragraph, please, on page 67. Tell us, what is a prokaryotic cell and how is it different than the cells that make up you and I? All right, how about Owen? Thank you, sir.
Kingdoms Archaebacteria and Eubacteria contain the prokaryotic organisms, bacteria. Prokaryotic cells differ from eukaryotic cells in two ways. First, their genetic material is not surrounded by a nuclear membrane. Instead of having a true nucleus, they have just a nuclear area, where their DNA is clumped together. Second, prokaryotics contain only organelles that are not surrounded by a membrane. For example, recall that mitochondria are covered by a membrane. Therefore, mitochondria are not found in prokaryotic cells. They are found only in eukaryotic cells. Ribosomes, on the other hand, do not have a membrane covering them. Therefore, they're found in both eukaryotic and prokaryotic cells.
Aha. So which one's more simple? A prokaryotic cell or a eukaryotic cell? Prokaryotes are definitely more simple, aren't they? And the big reason they're more simple is because of their lack of a nucleus. What? They don't have a nucleus? That's right. They don't have a nucleus. What? Remember the stuff that's inside the nucleus? What's inside the nucleus? Chromosomes, right? They still have chromosomes, but they don't have a nucleus. So here's the big difference. This prokaryotic cell has something in the middle, but it's not a nucleus. What it is, it's kind of like a nuclear blob. So they have no nuclear membrane surrounding their chromosomes. Their chromosomes are just floating around in their cytoplasm, not contained inside a nucleus. Isn't that weird? Now, prokaryotic cells are going to always be a lot smaller and tinier than a eukaryotic cell. They don't have very many parts and pieces. And they only have that nuclear blob. They don't have a true nucleus. So they're quite different, aren't they? Now, some things you need to know about prokaryotic cells. They are more simple and don't have near as many parts and pieces. They don't have near as many organelles in them. And that's why we say they're more simple. They don't have as many parts and pieces. Now, some really nifty and cool examples are the bacteria living in our world. The bacteria that love to get on your hands and your brothers and sisters' hands and all over sticky things. So bacteria are perfect examples of prokaryotic cells. Yes, sir.
So that means that the coronavirus is prokaryotic.
Ooh, good question. Viruses are not cells. Technically, a virus is non-living. And we're going to get into that. Viruses are like zombies. Are zombies living? Well, you know, it's fiction, but zombies are dead, right? But yet they can invade. And a virus is not a prokaryotic cell. It's more like a zombie. And we'll learn why, okay? We'll get there next. That's a great question. Yes, Davis?
What gives food its taste?
What gives food its taste? Basically, it's physical properties. Sorry, we don't have time to go into that one. Going back. Yes?
I also remember last year our teacher saying that viruses aren't living, so instead of like them like coming to your mouth, you have to like transport them. So like I have to touch my desk and like transport it to myself in order to get or breathe it.
Right.
It doesn't just like move itself, like walk to me.
So viruses can't move themselves. Now that's a great point. In fact, that leads into what we're learning next. Cells can move. Viruses cannot. We have to move them around. Like when we sneeze, or when we cough, or when we cover our hand and then we touch something, you know. Cells can move, and here is how they move. Look at this. This is a cell under a microscope. And check out these little fuzzy hairs coming off of it. That little cell can move and creep along from those little tiny hairs. Isn't that cool?
It's kind of.
Now, not all cells have those little hairs, but some of them do. And a lot of bacteria do. And that's how they move around. We call those little tiny hairs cilia. So why don't you do this? In your notes, define cilia, and then draw a nifty example in your notebook of what cilia look like. Just a cell with fuzz on it. In fact, you see an example in your textbook on page 67. The paramecium, it looks like a slipper, doesn't it? Like a little fuzzy slipper. Well, that paramecium has cilia, little tiny hairs that make it move. Yes, Jill?
Do we have that on our nose?
You do have nose hairs inside your nose. Now, technically they're not cilia, but they're kind of like cilia, but they don't help your nose move. Aren't you glad? Your nose stays intact and it doesn't move off your face. But those little tiny hairs inside your nose catch the dust particles you breathe in, and that mixed with your snot catches them, and then they dry out and they turn into boogers, and then you can get them out without breathing them into your lungs. So that's why God gave you boogers.
So little kids eating boogers are eating
Oh.
skin cells?
Ah.
Oh!
Yep, that's right.
Yeah.
Yes, Owen.
So it says on this little chart right here that's comparing them, it says that a prokaryote has a cell wall. Do all of them have a cell wall? Because I know in
Ooh.
eukaryotes only some do.
Great question. Prokaryotic cells typically have a cell wall, so they have an extra layer of protection. And you see why they need it, because their chromosomes are just kind of floating around, aren't they?
Yeah.
So, even though they don't have the covering on a nucleus, they have a covering of that cell wall to the cell. Great question. Yes.
Do nose hairs have cells that have that on them?
Your nose hairs are made of cells, yes.
But do our nose hairs have those on?
I don't know. We should pick. No,
Actually,
I don't think they do. We should pick one out and stick it under a microscope.
I thought that nose hairs were dead.
That would be awesome.
Yeah, they're dead.
And then we could see what was on the nose hair too. Wouldn't that be cool?
Oh no! That's called
Wow.
boogers and germs.
So I don't knows the answer to that.
Oh, that was.
But we should pluck out some nose hairs and find out. Alright, there's another way that cells can move along. Now, some of them have little tiny hairs that move around. Others have these giant tails that they can whip around.
Oh, I know.
Do you know what they're called?
Flagella.
Yes, flagella. So this cell here has one big flagella, but some cells have two, some cells have three, so some cells have multiple, okay? This specific cell has one flagella, and a flagella is a big, long, whip-like hair that it basically just flops along to help it move through liquids or move through its environment.
That's like a corn dog.
It kind of does look like a corn dog on a stick. Alright, so let's all add in flagella, please. You can see that's a picture of a cell with that flagella attached. A nifty tail that helps it move around. Yes, Tyler?
I thought that nose hairs were made out of dead skeletons.
Why are you using a
They are.
cells.
They are made out of dead cells.
Oh, but they're still made
Yeah.
out of
All hair is made out of dead cells.
It was, and then I continued it.
You guys are really interested in nose hairs, aren't you?
We all have them.
We do.
Do we
It's,
draw this?
it's science. Yes, please draw in your notes what a flagella would look like on a cell. Okay?
Cells are squarish or brick because of the cell wall.
Yes,
So
they always
why
have that.
aren't prokaryotes
Ooh.
square due to the cell wall?
All right, they are not. That's an excellent point. They are not that shape because they're not as rigid. Usually they're only, well, prokaryotes are always one-celled organisms.
So they don't
So
have
they're
to
always unicellular.
like combine their.
Right, they don't have to be stacked together like bricks.
Yeah.
Great question. All right, so let's do this. Let's continue along and let's compare and contrast prokaryotic cells with eukaryotic cells. Now, in order to do that, I have a video for you, okay? So what we're going to do is watch the video. So let me go ahead and pull out of this, and we will watch the little video to make sure my speaker is on for you. And like I said, I warned you, this video does contain some theory and some scientific fact. So I want you to be able to pick out fact from theory because you know, that's real life. You have to do that every day in life. You have to do that with the news that you watch. You have to do that with the science books that you read. That's just a good life skill, picking out scientific truth versus bad worldview. Yes?
Do you want us to take notes on the video or write down anything?
At the end of the video, I'm going to pause it, and there'll be a Venn diagram, and we're going to pause it with that Venn diagram and write some more notes, okay? Excellent question. All right, so here we go. This video, I'm going to stop it and pause it multiple times, just so you know. But let's go ahead and pay close attention. Here we go.
On Earth, there are two major types of
Our sound is not coming through, is it? All right, I'm going to try this again. See if I have sound this time. Yeah, much better.
On Earth, there are two major types of cells, prokaryotic and eukaryotic. Prokaryotic cells are the simplest and most ancient types of cells. They were the only form of life on Earth for billions of years before eventually giving rise to eukaryotic cells. If you take a look at
Whoa, that was quick, wasn't it?
25 seconds in.
Did you find some improper worldview in here? In other words, theory told you as though it was fact, and not told that it was theory. What did you discover, Miss Ove?
Yeah, they said like in the very beginning there was only one cell, like kind of cell, and then it evolved
you know that evolutionary scientists try to convince us that we all came from one cell and we evolved over time. So evolutionary scientists say we started off as this type of cell and it evolved into this type of cell. Now, this one is more simple, isn't it? And this one is more complex. But let's think about this. Evolutionary science also tells us, remember this is their own theory, they say that plants came first and evolved into animals.
So we're all
Which cell is more complex here?
The plant.
The plant cell has more parts and pieces. It's more complicated. So this doesn't match the theory, does it?
No.
So you can see they're trying to convince you of a worldview that's not factual, but is only theoretical. Alright, so good job picking that out. Let's continue watching the rest of the video and see if we can pick out the true science, okay? Alright, here we go. We'll continue on.
Prokaryotic and eukaryotic cells side by side, you can see a number of differences. To begin with, prokaryotic cells are a lot smaller than eukaryotic cells and have a simpler structure. But bear in mind that this simple structure is actually a good thing for prokaryotes because it allows them to reproduce very quickly and very effectively. If you were to look inside a prokaryotic cell, you would probably be surprised at how simple it is. For example, prokaryotic cells lack a nucleus. In fact, the name prokaryote actually gives you a hint about its structure. Kary means kernel or nucleus, and pro means before. So basically the word prokaryote means before nucleus.
Wait now. Did y'all catch that? Scientists have hijacked this term, haven't they? Even the very word itself, before a nucleus, they're saying this cell was here before a nucleus existed. So when were the two domains invented? The last 5 or 6 years, right? That's when scientists started with the classification. Now we know that God made prokaryotic and eukaryotic cells from the very beginning, though, don't we? So you can see where even scientists are trying to hijack some of the words to put in their evolutionary ideas, aren't they? Isn't that sad?
That's cheap.
Just give us real science, right? Don't teach us theory as fact. All right, we need to move along, okay?
Can I say one quick thing?
Yes, you may.
Is that I also saw a second ago under the eukaryotic it said 2.7 billion years ago, and non-evolutionary scientists know that
Right,
we've not been here that long.
right. So, creation science, we know that God made everything in the beginning, right? And that was not billions and billions of years. Okay, great point. All right, let's continue the video.
The inside of the prokaryotic cell is basically an open unit with no compartments. There are no membrane-bound organelles. However, small structures called ribosomes are scattered throughout its cytoplasm. The cell's DNA is located in a region of the cytoplasm called the nucleoid region.
All right, so it's a
The nucleoid
blob,
region is
isn't it?
not the
It's
same
not a
thing as a
nucleus.
nucleus because it's not enclosed by a membrane. Prokaryotes also have a cell wall that surrounds the plasma membrane. The composition of more flagella, which are used for movement. In contrast, eukaryotic cells contain a membrane-bound nucleus and other membrane-bound organelles. The name eukaryote also gives a hint about its structure. Eu means true. And remember that kary means nucleus.
Oh, that makes
So
sense,
in
right?
essence, the word eukaryote means true nucleus.
Ah.
Eukaryotic cells are larger and much more complicated than prokaryotic cells. However, they do share a few things in common with prokaryotes. Let's take a look at a Venn diagram to compare prokaryotes to eukaryotes and to also see what areas they have in common. Let's start with their commonalities. Both prokaryotes and eukaryotes have DNA as their genetic material, have
True.
ribosomes, have cytoplasm, and have a plasma membrane.
All right.
Now let's look
Very
at some
true,
of
right?
the ways they differ. Prokaryotic cells are the oldest type of cell. They're small and relatively simple. Eukaryotic cells evolved from prokaryotic cells later. They're larger and much more complex internally. Prokaryotes lack both a nucleus and membrane-bound organelles. Eukaryotic cells have a nucleus and also contain organelles. Prokaryotes are single-celled organisms. Eukaryotes can be either single-celled or multicellular.
Absolutely.
And finally, the DNA of a prokaryote is usually organized as a single circular chromosome, while the DNA of a eukaryote is organized as linear chromosomes.
All right, I'm going to pause the video here. In your notes, let's record this Venn diagram. But hold on. I want you to pick out the true science from the bad worldview. Okay? So make this Venn diagram, record it in your notes. You're comparing and contrasting prokaryotic cells from eukaryotic cells and telling how they are both alike. Now you're going to leave some of this information out, right? Which information would you leave out because it's not scientific? It's bad worldview.
What is cell type and evolved from prokaryotic?
All right, let's please leave those out of your notes, okay? I'm not going to tell you that's true science because it's not. That's theoretical science, isn't it? So I want you to write down the true science, the parts and pieces we do know that are true in this Venn diagram. Yes?
Is plasma membrane the same as cell membrane? Are they the same thing?
No, plasma membrane, that's what is around the, no, I'm sorry, it is. I'm sorry. That is the cell membrane, yes. My apologies. Yes, Tom?
Are we gonna turn this in as we leave?
Yes.
Okay.
All right, so as you guys work to finish that up, I'm going to explain what we need to do here next, especially for our virtual students. All right, virtual students, remember you have 2 assignments you need to get to me. You have the living cells are made of these. Please turn that in via Google Classroom. You also have your egg osmosis experiment. So make sure and turn that in to me on Google Classroom as well. Now your Friday homework is to continue working with prokaryotic and eukaryotic cells. You're going to pick this up on the way out, students in class. Those of you virtual students, you will do this at home. You'll read the material on prokaryotic and eukaryotic cells, and then tell me how they're alike and different on the back side. So that reviews prokaryotic and eukaryotes. Now, you have a second piece of homework for Friday. You're reading about what we're learning next week. Photosynthesis and cellular respiration. You read the literature on the front side, and you answer the 15 questions on the back side.